Hey guys, welcome to how to sketch angles in radians and degrees and how to find positive and negative coterminal angles. So what you guys are about to see, we're going to go over what exactly does it mean to be coterminal, and we're going to do this in 4 examples of sketching angles on a coordinate plane. We're going to do it in radians, we're going to do it with and degrees. We're going to find coterminal angles. We're going to do it positively and we're going to do it negatively. We're going to do it all at once. So here we go. Okay, if one was to sketch the angle 135 degrees and find one positive and one negative coterminal angle. So let's do first things first. So let's sketch the 135. So on a coordinate axis, this is 0. Right, straight up and down is 90. If we keep going, then this is 180 over here. So where does about 135 fall? Well, it falls between 90 and 180. And where exactly does it fall? Well, it falls right in the middle. 135 is right in the middle of 90 and 180. So the angle will get drawn literally right through the middle like this. So it starts over here, just like that. And that is the angle 135. So now we need to find a positive and negative coterminal angle. And what does it mean exactly to be coterminal? Well, coterminals have the same starting side and the same ending side. However, they may be more than one rotation, either positively or negatively opening. So like right now, this is 135 degrees and it opens counterclockwise. Well, what is an equal angle to that? Well, what if we went, instead of counterclockwise, what if we went clockwise and we went this way? What angle would that be? Well, if we go all the way around, that's 360. We know we go all the way around except for 135. So what is 360 minus 135 if we're going the other way? Well, 360 minus 135 is 225. But it's in the negative direction. So this is negative 225. So one negative coterminal angle would be negative 225. One positive coterminal angle, so negative, we just have to go the other way. And we figure, okay, well, how many degrees did we go the other way? Well, to get a positive coterminal angle, maybe we don't go around. So we go around, there's 135, we're all the way around, there's 360. What if we come back around and do that? How many degrees is that? Well, we went 135, and then we went 360 more. So what is 135 plus 360? Well, 135 plus 360 is 495. So that angle could also be 495. So the angle that we sketched in yellow was 135. A negative coterminal angle could have been negative 225, and a positive coterminal angle could have been 495. As you can see, if we keep adding 360 to this, we can keep getting different angles, different coterminal angles. So there's not just one coterminal angles. There's many ways to do these, and you could get many possible answers. So let's see another example. Let's start in yellow again. Sketch the angle negative 225. Okay, so let me put up my, let's see, that's 0. If we're going negative 225, this means we're going clockwise, or we're going this direction. So if I'm going that direction, negative 90 degrees would be here. If I keep going, this would be negative 180. If I keep going, this would be negative 270. Oh, that's too much. So we know the angle's in here somewhere. Okay, well, it's actually exactly in the middle, again, of here. Right, we saw negative 225 on the last example. So we actually open up this way, and that's negative 225 degrees. Okay. Find one positive and one negative coterminal angle. Well, the positive coterminal angle is just simply if we open it up this way, right? If we open up this way, like we saw from the last example, that would be 135 degrees. So that's our positive coterminal angle. And then a negative coterminal angle, well, maybe we don't just go one revolution to 225, maybe we keep going again. So like I said, maybe, oh, green's a fun color. Maybe we don't just go one turn of 220. So there's negative 225. What if we go again, right? Well, that would be 225 plus 360. Sorry, negative 225 plus negative 360. So what is that? 585. Negative 585. So there's a negative coterminal angle. There's a positive coterminal angle. And in yellow is the sketch of the original angle asked. So to find coterminal angles, A, just go the other way around. B, go another revolution around and add or subtract 360 depending if you're going positive or negative. That's it. Or you can keep going. Add 720, add 1080, add however many more revolutions you want to go around. The possibilities are literally endless. So let's go next. Oh, 5 pi over 3. What is that? So sketch the angle 5 pi over 3 degrees. Sorry, that should totally not say degrees. That should say radians. Because these aren't degrees. These are now radians. We've switched up the scale. And find one positive and negative coterminal angle. Okay. How do we deal with radians? Well, radians split this whole thing up basically into a pi, where the whole thing around is 2 pi, and half away around is pi. So from here to here is pi. If we go again, that's 2 pi. So one full revolution is 2 pi, which means if we go to here, this would be pi over 2, pi, and now 3 pi's over 2, or 3 halves, and then 2. So it goes half, 1, 3 halves, 2. But we need to find where 5/3 would sit on this whole thing. So between 0, so this is 0 and 2 pi. This guy is here. These are coterminal, 0 and 2 pi. Let's see. So if we need to cut this guy into thirds, they go about that, right? 1/3 is pi over 3. 2/3, 2 pi over 3. 3/3, 4/3, 4 pi over 3. 5/3, 5 pi over 3. So 1/3, 2/3, 3/3, 4/3, 5/3. This would be 6/3, also 2. So 5/3 is here. So let me erase everything else that's not that. And let me put in our arrow. So this was our initial side. And that revolution there will put us at 5 pi over 3. So that's our sketch of 5 pi over 3. Find one positive and one negative coterminal. So positive coterminal angle. So positive. We started at 5 pi over 3. If I wanted to go another revolution around, I would just add 2 pi. So 5 pi over 3 plus 2 pi. 5 pi over 3 plus 6 pi over 3, equivalent fractions. 11 pi over 3. There's a positive coterminal angle. Negative coterminal angle? Negative. Well, if we look here, so that was the positive direction. So what about going in the negative direction? If we go positively 5 pi over 3, then we would go negatively negative 1 pi over 3, right? Because 5 pi over 3 plus 1 pi over 3 would give us 6 pi over 3, gives the whole way around, so 2 pi. So this is just the remaining space. So going this direction, our negative coterminal angle, we could say that's negative pi over 3. And we're done. So just think of radians as literally splitting the coordinate axis into a pi, except for the whole way around equals 2 pi, and you're just finding fractions of that 2 pi. That's all radians are. Let's look now at negative 4 pi over 3, and how would we sketch that? So we're dealing with thirds again, so let me draw my thirds. So again, this is 0 or it's 2 pi. That's pi over 2, or 1/2. This is 1. I know it doesn't make sense because you think, well, one way around should be 1, and that whole thing should be pi. The whole way around is 2 pi. Think a circle. So half, 1, 3 halves, 3 pi over 2, and then we end at 2 pi. Okay, we're going to cut the thing into thirds now. There's 1/3. There's 2/3. That would be 3/3, which means this would be 4/3. So 4 pi over 3 would be there. So again, all I'm doing is cutting, and basically like cutting a circular cake. So here's our initial side. We always start from here. There's our terminal side. So this is the angle 4 pi over 3. Let's get a positive coterminal angle. So a positive angle that would have the same starting side and the same ending side. So our angle was 4 pi over 3. We could have the same thing if we just went there and then went around again and we end up there. So we add 2 pi to that. So 4 pi over 3, let's go equivalent fractions. That's 6 pi over 3. So 10 pi over 3. That would give us an equivalent. Or, let's do a negative now. So the negative, so that was the positive direction. The negative direction is just going the other way. So if that was 4 pi over 3, then this remainder here, so the whole thing is 6 pi over 3, or 2 pi. So the whole thing is 6 pi over 3. If that went 4 pi of the way, then this would be 2 pi of the way, or negative 2 pi over 3. Notice this amount plus this amount equals the whole amount, which is 2 pi. So think of it as 4/3 plus 2/3 equals 6/3. What does that reduce to? It reduces to 2. So we go 4 of the way, and then this is the extra 2 of the way. Okay, so but we go in the opposite direction. So this direction, this angle would be negative 2/3 pi. You can almost forget the pi and just think of it more as like fractions, like 2/3, 4/3, 1/3, all of that. But that would be our negative coterminal angle. So I hope that describes some stuff to you. Just remember, coterminal means we have the same starting side and the same ending side. It's just for degrees, add or subtract 360 from it, you'll get a coterminal angle. Or for radians, add or subtract 2 pi from it, and you'll get a coterminal angle that way as well. So I hope that cleared some stuff up for you guys. If you have any questions, please, please, please don't hesitate to ask. I'm here for you guys. I'll see you in the next video.